Hello class, we're down to our second to last chapter of notes, and this one is entitled for chapter 11, section 1, Circumference and Arc Length. That's circumference and arc length. Alright, so we need to go through our three definitions. The only difference between chapter 11 and chapter 10, chapter 10 we talked a lot about circles and their arc measures, so a lot of angles were involved. This time we're talking about more of the length, so we'll be talking more about radians, arc length, circumference, area in this chapter, whether it be circles or other polygons. So circumference is the distance around the circle. So this is an actual measure, unlike where we took the measure of a circle, which was 360 degrees. This one can vary depending on its size, while we talk about radius and diameter. Now the arc length is the portion of the circumference of a circle. So this is where we only took a small section of the circle. So the circumference is everything around the circle. The arc length will only be a small portion of that. Okay, so our last one is a radian, and this is a constant proportionality. So proportionality. Also, in its formula use, it is set like this. So that if we took the measure of an arc and divide it by 360 degrees, this is where that measure comes in, and then we multiply it by 2 and pi. And this measure of the central angle associated with the arc. Okay, so those are our three definitions: circumference, arc length, and radian. And so now we're going to go down to our core concepts. And our first core concept is the circumference of a circle. So remember, that is the distance around the circle. And that definition is expressed as a formula where the circumference equals equals pi times the diameter, or 2 times the radius. So remember, we have 2 and r and d are also related to each other. If I multiply 2 times the radius, I get the diameter. So that's why these can be written in two different ways. And so if we have a highlighter, please go ahead and highlight or underline that formula that you will need. Circumference equals pi times the diameter, or pi times 2 times the radius. So we have two examples. We have find the measure. One is the circumference of a circle with a radius of 9 centimeters. So we need to find, or what we need to find is the circumference. And we know that we are given the radius. So this is where I would use the second half, so 2 pi r would equal my circumference. So I have C equals 2 pi r. Okay, and we need to find the circumference. We're going to leave capital C, and then we still have 2 pi, and we know that our radius is 9 centimeters, so we're going to insert 9 here. And so their circumference will equal 18 pi, or expressed as a decimal, 56.55 centimeters. And here's how you would display this into the calculator using pi. So if you want to have an exact decimal, you can still leave it as 18 pi, but note that there is a small h here, right underneath the clear button next to the h. So I can do 18 and then hit second and hit the caret, or where pi is. So we have to have the arrow and then press the caret And to have 18 pi, when you press enter, you have 56.54, and we rounded it up to the nearest hundredths place. Okay, so that's how you would type it into your calculator. So let's try our second example. So our second example says we need to find the radius of a circle, and it has a circumference of 26 meters. So I would still continue to use 2 pi r because I know I have the radius, so that's what I need to find. And so I'm going to use the same formula. So I have c equal to 2 pi r, and we need to find the radius, but we're already given that the circumference is 26. So 26 equals 2 pi r, and then I can divide all of 2 pi. Okay, so r would equal 26 over 2 pi, and if I want to type this into my calculator, I can do 26 and go ahead and divide it by 2, and I'm left with 13 pi. So I have 13 over pi, so I can take 13 divided by second caret to get pi, and then I get 4.14 if I'm rounding to the hundredths place. So 4.14 meters. Okay, and so those are 2 examples on how to use circumference. So if we're turning over to our next page, we will talk a little bit more on arc length. Our next page talks about arc length. So in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. And so now we have 2 formulas, and you can use these whichever way. And so I have the arc length of AB would equal 2 pi over 2 pi r would give me the arc measure over 360, or if we just want to find the arc length, and then we have the measure over 360 times the 2 pi r. It's supposed to be a multiplication sign, so times 2 pi r, or in this 2 pi r in this case is the circumference. Okay, so another word to say 2 pi r is you can say c. So it can also be written as c for the circumference. Circumference is 2 pi r. So our first example is to find the arc length of AB. Now, if I want to find the arc length, I can go ahead and use the second one. So I have the arc length of AB equals our measure in this case, which the central angle would be 60 degrees. So 60 degrees is the measure of the arc, same as here, and then over 360. We already know that measure, the total measure of an entire circle is 360 degrees. And we're going to multiply it by 2 pi, and r in this case would be 8 meters. And so we can do 360, or 60 divided by 360, and then we can multiply that by 2, and then second caret, and then we have r, which would be 8. And we end up with a decimal of 8.38, rounding to the nearest hundredths place, and we're talking about meters. Okay, so that is an example of finding arc length of AB. Our second example is finding the circumference. Remember, the circumference was 2 pi r, and so we know that we can probably use the first one. So we know that the arc length of xy is equal to the measure of xy, so this part, I apologize, I'm missing a measurement. This is 4.19, that's how long this is. So I have the arc length of xy over the measure of xy divided by 360, or 360 degrees, and the arc length is all over the circumference, which is c. So now all I can do is plug my numbers. So I know the length of xy is 4.19 all over c, and the measure, the arc measure, is 40 degrees because of its central angle, all over 360. And so now I can reduce and cross multiply. So 40 divided by 360 gives me 1/9. So if I want to do that, I have 40 divided by 360. I end up with some large fractions. Remember, you can always hit math and select fraction. You get 1/9. So I have 4.19 over c equal to 1/9. And now I can cross multiply, or we talked about butterfly method some time ago. So I have 9 times 4.19 equal to c times 1 is just c, which is what we're looking for, which stands for circumference. And so when I type in 9 times 4.19, I end up with 37.71 for c. And that is our circumference. Okay, so that is our two examples involving the arc length. So we have one where you can find the arc length, or one you can find the circumference. And knowing circumference is 2 pi r. Okay, so now down to our last set of core concepts is converting degrees and radians. So remember we talked about different modes. And in this case you want your modes to be in radians. So if you hit out of your calculator, you turn it on, you go to mode, and remember we talked about radian and degree. Your calculator is probably going to be in radian mode, okay? And so in order to do this one, we're going from degrees to radians. We're going to multiply the degree measure by either 2 pi radians or pi radians over 180. So each one of these will work, and we'll try it with both, and you'll see the same answer. And so our first example, we're doing degrees to radians. So we want to convert 45 degrees to radians. So we're taking our degree measure, which is 45, and we're going to multiply. So we've got to multiply it by, let's try the pi radians. So pi radians, and yes, you need to keep the radians with it, all over 180 degrees. So note, if you are in chemistry or thinking about conversions, the degrees are going to cancel out because they're on top and bottom. And so we have pi still on top, and then we can do 45 divided by 180. End up with 0.25, or as a fraction is 1/4. So I have technically pi over 4 radians, or you can say rad for short. Okay, so let's see if I try the other one, do I end up with the same answer? So I take my degree, so 45 degrees equal to 2 pi, or multiplied by 2 pi radians all over 360 degrees. So I have 45 times 2, my degrees cancel out, so I have 45 times 2, I get 90 over 360. And then 90 divided by 360 gives me 0.25 again, or as a fraction is 1/4. So I do end up with the same answer as pi over 4 radians. And no, radians is usually going to have pi involved. Now for our other one, if we're going from radians to degrees, we're going to multiply the radian measure by 360 over, or 180 over pi radians. And so you see how they're flipped. So let's say if we want to convert 3 pi over 2 radians to degrees. So I take my radian measure, so 3 pi over 2, and multiply it by 180 degrees. I'm going to take the second one, all over pi radians. So pi over pi cancel, so the pi's are gone. And so I'm left with 3 times 180 degrees all over 2. So I have 3 times 180, which gives me 540, and then divided by 2, I end up with 270 degrees. And so those are our two examples in converting degrees and radians and vice versa. So let's move on to our next page where we'll practice. Moving on to our next page, we have the extra practices, and so we need to find the indicated measure, and this is where we're using circumference, or we're finding arc length. So So this one is asking for the diameter with the circumference of 10 inches. So remember, our formula for circumference is C equals pi times the diameter, or 2 pi the radius. And so since this one's talking about diameter, I'm going to use the top one. So I have C equal pi times the diameter. And it already tells us that we have a circumference of 10 inches. So we have 10 equal to pi times diameter. We're going to divide by pi. And so D would equal 10 over pi. And then remember, in our calculator, we can do 10 divided by our second caret, and then we get 3.18 inches for our diameter. So let's move on to our second one. We need to find the circumference with a radius of 3 centimeters. So this one we have radius, and then we have circumference. So we're going to use 2 pi r for this one. So C equals 2 pi r, and we don't know what the circumference is, so we'll leave it as C, and then 2 pi, and this is the radius of 3. So we're plugging that in for r. So we know that C equals 6 pi, and so we have 6 times second caret pi, and we get 18.85. And that is centimeters. Our next one, we're trying to find the radius of a circle with a circumference of 8 feet. So we're talking about radius, so we're going to use the 2 pi r again. So C equals 2 pi r, and we're trying to find the radius. Our circumference is given as 8 feet, so 8 equals 2 pi r, and we can divide 2 pi all together. You may do this one at a time, divide by 2 and then divide by r, but each way works. So we have 8 over 2 pi equal to r, and we already know 8 divided by 2 gives me 4. So r is going to equal 4 all over pi. So 4 divided by pi is going to give me 1.275. And that is in feet. Our next one, number 4, I'm going to move this up some. We need to find the circumference of a circle with a diameter of 2.4 meters. So this time we're going to use the pi times diameter. So circumference equals pi times the diameter, and the diameter is 2.4, so the circumference is pi times 2.4, and if we were to type this into our calculator, we end up with 7.54 meters. Okay, and our last, one of our few ones, we need to find the arc length of arc AC. So this is our arc length, and so remember, arc length, we can use the previous formula. So if we have the arc length of AC is going to equal the measure of arc AC, and then it's going to be divided by 360 degrees multiplied by 2 pi r. So we know that the measure of AC, this is a central angle, so this is 70 degrees, and AC is also 70 degrees, and 3 becomes our radius. So because any distance from the center to the edge of the circle is called a radius. So 3 is the radius, so I can plug in my numbers. So I have 70 degrees all over 360 degrees multiplied by 2 pi, and then I have 3 as my radius. So 70 divided by 360, and then I can multiply that answer by 2 second pi 3, and I end up with 3.66, or I can say 3.67. And this is in inches. And you can always do this separately. You can take 6 pi times this and multiply across, then divide by 360 at the end. Either way, you should end up with the same answer. Okay, down to our last 2 questions, and it's converting the angle measure. So I want to convert 60 degrees to radians. So note we're converting degrees to radians. And so we're converting degrees to radians. We're going to take our measure, so 60 degrees, multiply it by 2 pi radians. So we need that on top because we need radians on the top, and then all over 360 degrees. And this is where we want degrees to cancel. That's why it kind of helps using conversion factors. So the degrees are going to cancel out. We don't need them anymore. And on top, we are left with 60 times 2, which gives me 120 pi all over 360 radians, or you can say rad for short. And then I am left with 120 divided by 360. And I can put this as a fraction by using math. And it's 1/3, and so there's an imaginary 1 there, so it would be pi 3 radians. Pi over 3 radians. Okay, so that is converting degrees to radians. Our next one, we're going to do radians to degrees. So this is where we have to go the other direction. So I have 5 pi all over 6 radians multiplied by, you can do 2 pi over 360 or pi over 180. So we're going to do pi, or 180 over pi. So 180 degrees all over pi radians. So note the pi radians cancel out on both sides, and I'm left with degrees on top. So I have 5 times 180, which gives me 900, and 900 divided by 6 gives me 150 degrees left. Okay, and so that completes our 11.1 notes. Note, if you have any questions, please feel free to find me on Remind. I also have these notes uploaded to YouTube, Canvas, as well as Hangout on Remind. I have tutorials on Wednesdays and Thursdays from 3 to 4, and I'm available in the morning at 6:50. Thank you so much.